So as you can see, here's the fully classified image of Chicago in 1984. And over here we have the fully classified image of Chicago in 2010. This is both of them utilizing an unsupervised classification method. So now that we've got that, we are going to combine both of the images using the matrix process to actually visualize the change that's been going on between these two. So to do that, we go into Interpreter, you go under GIS Analysis, and before we actually do the matrix, we're going to recode it. Recoding the images, we use that to, since I have multiple classes of urban and multiple sources of water and built up and other and all that stuff, we're going to actually simplify that into just 3 workable classes. So you do that, you go to recode, you go to input file, and you do both of your classified images, and then after that, I go to recent, classified, and then here you actually set up the recode, otherwise you don't do anything. Very important step. And so then you assign all the classes to either water, urban, or other. So for me it was either 1, 2, or 3. So after doing all that, going down steps, after that you set the recode, you output the file to where you want it to be, and then you press OK, and then all the files show up just the way they are, except now your images is in a workable state. So now that we got through all that quickly, here are the 2 recoded images of Chicago in 1984 and Chicago in 2010. So now what we're going to do is we're finally going to get to the matrix. We're going to combine these things and see what change actually went through. So we go to Interpreter, GIS Analysis, Matrix, and right here you would add 1984, and over here you would add 2010. So you wouldn't need to set up the recodes here. You keep all these standard and then press OK. And so when that happens, you will get a combination map utilizing both of the classes to show the change in the area, and this is the change right here. Alright, got the change up nicely. Favorite window. Excuse me. So as you can see, we definitely saw some change around here. As you can see, I posted these different colors. I classified new classes into different colors to show where the changes actually occur. As you can see, it's not just cyan anymore. There's cyan, and there's turquoise, there's magenta and purple and gold and yellow to show all the different changes that I had. And so basically my classes came down to urban unchanged, other unchanged, urban to other, and other to urban, and water to urban, and water to other. So those are the only dynamics that I observed in my change detection of Chicago from 1984 to 2010. As you can see here are all my classes. So very simple stuff. So now that we've gotten the change detection out of the way, we visualize change, we can see it now. And so now what we're going to do is, our final step is we're going to do an accuracy assessment to see how well I classified each of the images, and hopefully there's not a whole lot of mistakes. So in order to do that, what we're going to do is we're going to go to Classifier, Accuracy Assessment, okay, and then go to view. No, wait, no. First we go to open, and then you would select the change detection file, which mine is Matrix Chicago. Then what we do is select the viewer. There we go. And so with this shows the class and references at 20 different points. And so what we would do right now is create and add random points, keep that to 20, stratified random, and then select our classes, which would just be all my three, unchanged and or other unchanged, urban unchanged, urban to other to urban, etc., etc. And so then we get that, and then I would go through each of the points on the map and then compare it to the references I was giving in the accuracy assessment viewer. And then after that, once everything was compiled, I would make sure these three are checked: error matrix, accuracy totals, and Canvas statistics. And then I would produce an accuracy report. And since I already did that, let's skip that step, and I have it here somewhere. Here we go. Here was my error matrix for Matrix Chicago. And as you can see, going through all these numbers, in the end, I had an overall accuracy classification of 85%. So it's not that bad. Most likely my errors in this project resulted from a very large image. I probably should have subsetted in AOI, made it smaller, too many images, and just general human error. I guess I didn't have a keen eye for where some of the other and urban areas overlapped. And yeah, that's about it. If there's one thing I could change about this, I would definitely subset it a much smaller area so I can focus the change a lot better, specifically in this area along the coast. And that's pretty much it. That is basically the full change detection of the Chicagoland area from 1984 to 2010 and its urban sprawl. Thanks for watching. Goodbye.